Yeah, so last week we learned to add, subtract, and multiply them, and you're like, there's another normal operation, because normally like the 4 mathematical operations are add, subtract, multiply, and divide. But we didn't divide yet. We're going to spend a lot of time dividing polynomials. Now, adding and subtracting, easy. Multiplying was the box method. Dividing is also sometimes called factoring. But we're going to spend time just plainly dividing today. And we're going to use one of 2 methods I will teach you. Today is the first method. Next class, well, the next class is your map test, but the class after that, we will learn the second method. So we are dividing polynomials with long division. OMG. Do we remember long division from elementary school? It's been a minute, right? So I'm going to reteach it to you because the steps that you used in elementary school to do long division will be the steps that you use to long divide polynomials. It just gets harder because they're not plain numbers, they're entire math equations. So some vocabulary to remember. When you do a division problem, the number you put inside the little house is called a dividend. Say the word dividend. The number that you put outside of the house is called the divisor. Divisor, say that. And the answer you get is called the quotient. Q-U-O-T-I-E-N-T. Quotient. That was what you would call the answer. So if I asked you what's 6 divided by 3, you'd say 2. 2 is the quotient. Now also sometimes when you did division in elementary school before you learned about the world of decimals, you'd have some remainders. Do you remember like the remainder thing? Okay. You're going to have remainders, and the thing that you do with remainders is that you always, especially for this class, take the remainder that you get and you divide it by whatever the divisor was.
That's like when you get decimals?
That's where we got decimals from, yes, because when you did this in elementary school, your remainder might have been like 1 when you were dividing by 4. So you'd put 1/4, and then we started learning about decimals, and we're like, oh, 1/4, that's 0.25. So we started learning about the world of decimals and stopped using remainders. But we're going to go back to using remainders when we do long division and synthetic division next time. So the steps for long division are the following. We have divide, multiply, subtract, bring down, and repeat. Those are your steps that you're going to do for long division. Every single time. You might have to repeat those steps multiple times because, again, the last step is repeat. These same steps that we're going to practice with these regular numbers will apply to polynomials as well. To help you remember this, I have whoa, I just lost my train of thought for a second. I have a cool little video to show you. Hold on. Divide, multiply, subtract, bring down, repeat. Now, when I say divide, I am meaning for you to divide this number, the divisor, by the first number in the dividend. Can 4 go into 1? No, so when I'm doing long division, if it can't go into the first term, you scoot over to the second term. Can 4 go into 15? How many times? 3. Okay, so I put a 3, but I'm going to put that 3 above the 5, not the 1. That's the divide step. Then I'm going to multiply the number I just wrote down, 3, by the divisor 4. So what's 3 times 4? 12. So I write a 12 down right here. We've divided, we've multiplied. The next one is to subtract. So I'm actually going to write, let me change the color scheme here actually to help this out. We're going to subtract. 15 minus 12 is how many? 3, and then I'm going to bring down just the next digit in this number and write it down. Divide, multiply, subtract, bring down. The last step is to repeat. So this time, I want to divide 38 by 4. 9. 38 divided by 4 is a perfect 9. However, I'd have some numbers left over. I multiply just the 9 times the 4. 9 times 4 is 36. We've divided. We've multiplied. What's the next step? I heard somebody whisper it. Subtract. So I'm going to subtract 38 and 36. I would get 2. Bring down the 5. And repeat. We're going to divide 25 by 4. 6. The best it can do is 6. And then we multiply 6 times 4 and write it down, 24. We subtract. Is there anything left to bring down? No. So when you started learning more advanced math, you put a decimal and a 0, brought down a 0. We're not doing that. We are going to be okay leaving the remainder as a fraction. So I'm going to take this, which since there's nothing left to take down, this is called the remainder. And I'm going to write it next to the number on top, the quotient, as plus whatever the remainder is divided by the divisor. So 1,585 divided by 4 is 396 plus 1/4, or and 1/4, and a remainder of 1. Those are the sort of things we're doing. Does that sound familiar from something we've learned like ages ago? Sort of, maybe, hopefully. Can I give you one to try? It's just another long division problem. Okay, on your paper, I want you to try 2,576 divided by 3. Give it a shot. Okay, let's see how we did. I know I'm cutting some of you off from thinking, but if we're doing 2,576 divided by 3, I start by dividing what two numbers? 3 and 2. Does 3 go into 2?
No.
Okay, so we scoot over 1. What next? 3 and 25. 25 divided by 3 would be 8 point something, so we use the 8. Therefore, 8 times 3 is 24. I subtract those two numbers, I get 1. I bring it on down, and I bring it on back. I heard a hold up. What's up? Oh, sorry. Once I've got that number after the subtraction and I brought it down, I repeat. But this time I am doing 17 divided by 3. What's 17 divided by 3? 5 with some left over. 5 point something. We use 5. So 5 times 3 is 15. We subtract. 17 minus 15 is 2. Bring it on down. Bring it on back. 26 divided by 3. The closest I can get again is 8. And 8 times 3 is 24. What's my remainder? 2. So the way that I, again, would write the actual quotient here, the answer would be 858 plus the remainder divided by the divisor, which is the number 3. Yes? We see the steps?
Yeah.
Dusted off that. It's in our file cabinet of a brain, but it's way back when. Okay. Using this idea, though, of long division, we're going to be able to do long division with polynomials. The steps are exactly the same, and the steps are here to the division family. It has another way to remember it. I always just sing the song to myself, but if remembering it's a family, dad, mother, sister, brother, Rover. Rover's the dog. Okay. You can use this division family to help you remember. So some things that we have to make sure we know for setting up polynomial long division. This is going to be super important, so let's put a little bubble around this. This is the information that translates it from just long division for regular numbers to polynomials. When setting up a polynomial long division, use 0 as a placeholder if any terms are missing. So if your exponents go from 5 to 3, we were obviously missing the number 4, correct? We would put a 0 in the spot of the 4. When you are subtracting, you subtract all of the terms of the polynomial, and that's going to be the part where we mess up because that's tricky when it comes to polynomials. We're not subtracting just the first term, we're subtracting all of it. So to help you out, when I do this step, I'm not actually going to subtract. I'm going to change all of the signs so that I add the opposite. And hopefully that will help you correctly add the right numbers. So we're going to change all of the signs, just like we did when we were subtracting polynomials last week. We changed all the signs and then added them together. But at the very end, it will still be the quotient, so the things you get on top, plus the remainder divided by the divisor. Hang on with me. These are a little funky looking. We're going to use polynomial long division to solve the following. We're going to put the dividend, which is x squared plus 6x plus 12 inside the house, and x minus 3, which is the divisor, on the outside of the house. So it's set up just like regular long division. They're just polynomials. Okay. Do you see how there are two terms in your divisor? So I don't want to start at the first term. I want to start at the second term. So skip this step. Like how we skipped the 1 or the 2 in the problems before this because they didn't go into it. Two things cannot go into one thing. Two things can go into two things. So I'm going to start writing the first number here. I'm still doing divide, multiply, subtract, bring down, repeat. The first thing I'm going to divide, though, is x squared divided by x. Where did I get those things from? X squared divided by x. What is x squared divided by x? Ooh, then we have to remember exponent rules. X squared divided by x to the first power. Ooh, that if we were multiplying them, you would add them together, yes. But if we're dividing them, do you we subtract them, so how many are left? Just x. Very good. So x is what I'm going to put at the top for the first part of my quotient. That was the divide step. Then I'm going to multiply. The crazy part is I have to multiply this by all of this, which means the problem kind of looks like this. X times x minus 3. So the number I put on top times everything on the side. This is now a distribution problem. X times x is x squared. X times negative 3 is negative 3x. Whew. When I multiplied it with just plain long division, I went ahead and put that number underneath the dividend, which is what I'm going to do here. Divide, multiply. Now I need to subtract. But I'm going to subtract every single thing, which is confusing. So instead of just leaving that subtraction sign there, I'm going to act like I did when we did subtraction last week. And I'm going to change all of the signs of the stuff I've written in red. So don't write for a second. Look up at the board. Watch me do this. Change, change, change. Do we see that? Change the minus to a plus, pluses to a minus for everything. When you do that, you can now add like we did last week, just straight down. X squared plus negative x squared is going to cancel out. Gone. 6x plus 3x is how many x's? 9x. Divide, multiply. That was subtract. What's the next step? Bring it on down and bring it on back. Do it again. Oof. I know, it's gnarly. This time when I divide, I'm going to divide 9x divided by x. Where did that come from? 9x, x. So you're always dividing the two terms by that first term in the divisor. What is 9x divided by x? 9. Because the x's are going to cancel out. So I put a 9 up here, but here's the thing. In a polynomial, do you just leave the terms next to each other like that? What's always in between the terms?
Plus.
Plus or minus, right? Did we say negative 9 or did we say positive 9?
Positive 9.
So we're going to put a plus right there. Okay. That was divide. Now I need to multiply. I'm going to multiply 9 by the entire divisor. Multiply, multiply, that is 9x minus 27. So that's what I write here. Divide, multiply. The next step was subtract, but I told you you're going to mess up if you try to subtract, so what should we do instead? Change all the signs. Change, change, change. I have 9x minus or plus negative 9x. That's going to cancel out. It should. The first thing always should cancel out. If it doesn't, you've done something wrong. And then I can just add 12 and 27. That's going to be 39. Is there anything else to bring down in this polynomial? No. So what is this called? Our remainder. So to write my final answer, I'm going to take the stuff on the top, x plus 9, and I'm going to add the remainder. This would become the stuff from the top, x plus 9, plus the remainder divided by the divisor, which in a polynomial is not a number. The divisor is the stuff on the outside of the house. Stuff on the outside of the house was x minus 3. The steps are the exact same from numbers to polynomials. It's only harder because we're using polynomials. Before we move on to the next one, please ask me a question about this because I know there are moments where you got lost because it's confusing. So think of questions as we go, and I want you to stop me when you're lost. For number 3, number 2, sorry. I want you first to set it up. What would the house look like for this problem? Set that up without me. Okay, did you do this? Did you do 4x cubed plus 13x squared plus 27x plus 6 on the inside and 4x plus 1 on the outside? Did we do that? Great, we can set them up. Amazing. Now we need to do our steps. The steps are saying to divide, multiply, subtract, bring down, repeat. The first time we divide, we're dividing something from the dividend, this number, and something in the divisor. What are 2 things are we actually dividing here to figure out our numbers? Look at the work we did on the problem number 1. The first thing we wrote on the side, what did we divide? X squared and x. Where did those numbers come from? Where else in the problem is there an x squared and an x? The dividend, the first number in the dividend was x squared, and where was x? In the divisor. So we divided the first term in the dividend by the first term in the divisor. I'm going to continue to show the work on the side. You don't have to show that work on the side, but I think it's helpful while we're learning. So the first thing we're doing is 4x cubed divided by 4x. The first term in the dividend, first term in the divisor. Okay, what is 4 divided by 4? Just start that easy. 1. What is x cubed divided by x to the first power? X squared, because it was 3 over 1, so we subtract them, just 2 on top. So this is just 1x squared. Okay, phew. That should go over the other x squared term. You see how these match up right here? X squared over x squared. Okay, great. We've divided. What's the next step?
No.
Multiply. And I'm going to multiply the thing I wrote just on top by the thing I wrote on the side of the house. X squared times 4x is 4x cubed. X squared times negative 1, I'm doing this distribution, is negative x squared. That's what I'm going to write down here as the next step in my problem. Again, once we get good at this, if you don't need to show this work on the side, you do not have to. It's not required. This is just to help show you what I'm doing in my head. Okay, so we've divided, we've multiplied. What's next? Subtract. But I don't want to subtract because that's confusing. So instead of subtracting, what do I do? Add all of the opposites. Change, change, change. Then we actually subtract 4x cubed plus negative 4x cubed. The first thing should always cancel. Again, if it doesn't, you've done something wrong. And then we have 13x squared plus 1x squared. Hold on. Oh, I see my mistake. I was like, my key is different than what I'm doing. I messed up here. What's my dividend? Is it minus 1? Plus 1. So I just messed up right here. My bad. My human is showing, which means this is plus, which means this originally started as a plus. So when I change the sign, It shouldn't be a plus anymore. It should be a negative. My bad. There's my human moment for today. And so when we do 13x squared plus negative x squared, we should get 12x squareds. Bring down. Repeat. Okay, to repeat, I need to do a divide step. What two things am I dividing here?
4x by 12x squared.
Yes, so the first term in the new thing that I just subtracted by the first term in the dividend. Sorry, divisor. I said that backwards. Okay, let's take this easy. 12 divided by 4, 3. X squared divided by x, just x. Cool. And that's positive, so I'm going to put plus 3x. We're going to multiply 3x times 4x plus 1. Make sure I write plus this time. That's a distribution problem. 12x squared plus 3x. Okay, so that was what I got to go here. 12x squared plus 3x. Again, the stuff I'm writing little on the side is the thought process that you might be able to start doing in your head once we get good at this. We've divided, we've multiplied, we subtract, but ew, I hate subtracting, so instead, add the opposites. Change all the signs. Change, change, change. 12 plus negative 12 cancels. It should cancel. Has to cancel. And 27 plus negative 3 is 24x. Bring down. I got to keep going. Okay, what do I divide this time?
Uh,
24 by? Very good. So I have the first term in the new blue part divided by the first term in the original divisor. 24 divided by 4 is 6. X divided by x cancels each other out, so it's just 6. I ran out of room. I would then do 6 times the entire divisor, making sure I write it down correctly. That's 24x plus 6. Ooh. What do y'all think is going to happen?
No remainder.
There's not going to be a remainder here. Because when we go to subtract that thing, and I add all of the opposites, both of these things are going to cancel. Which means I have no remainder. And that's okay, that's going to happen. In fact, later on in this unit, we're going to want that to happen. It will help us factor polynomials. Right now, we're just dividing. So our quotient, our answer, if you will, is going to be x squared plus 3x plus 6 with no fraction behind it because I have no remainder. Like technically, you could write plus 0 divided by 4x plus 1, but like, we don't need it. If you get a remainder of 0, you just stop at the end of the normal looking polynomial. Yes, ma'am?
So whenever we do like the divide thing, that's the answer that we put for the quotient?
Yes. The numbers you get up here, which is all of the things you got when you did the divide step, that becomes your quotient.
So the subtract part is just to get us to the next step?
Yeah, the subtract part is just to allow you to be able to bring down and do it again to the next term. Any other questions? Because the next one is a little bit harder and I don't want to do it if we're not ready. Let's try it. Now, this one, the steps are still the same. There's just a trick to it that we've kind of been skipping the whole time. When I write down the house for this one, it should actually look like this. And I want you to tell me why I wrote it like this. This should be 7x cubed plus x squared plus x plus 3 on the inside, and x squared plus 0x plus 1 on the outside. Whoa. Why did I write it like that?
Because you need to substitute the value for x.
We said, yeah, in that little part I had you, the word blurb, I had you bubble or circle on the front or other page of this, said if you are missing any terms in either the dividend or the divisor, you have to put a placeholder 0. Do you notice that in our divisor, it goes from squared, missing the x term, to the constant? You have to be aware that that could happen in either this part or this part that you have to put a 0.
So if it's not like that, you don't have to do it.
Correct. So just don't write this down. I just want y'all to look. Let's say I asked you to do x cubed plus x minus 1 divided by, don't write this down, remember, x minus 1. What term am I missing?
X cubed.
I see x cubed. I'm missing a squared, am I right? Doesn't this go from 3 to 1? So this time, if I were to write this in the house, it would be x cubed plus 0x squared plus x minus 1. And there's nothing missing in this one, so there's no zeros. So that 0 could show up either in the dividend or the divisor. You always got to be on the lookout for those. Okay. I digress, though. Let's do this one. We divide. What have we been dividing the whole time? Polynomials, yes. The dividend by the divisor. What part of both of those? Like the second, third part? The first part of both of them. So I'm going to show you my thought process on my work. I'm going to divide 7x cubed. Divide by what?
X squared.
X squared. So 7 divided by 1 is 7. X cubed divided by x squared is how many left over? Just x to the first power, right? Okay, great. Now here's the thing. I got to know where to put this correctly. Should I put it here in the first spot? Should I put it in the second spot? Should I put it in the third spot? Yes, because that spot has the x in the dividend, so that's where I'm going to put 7x. These have to match up, the x's. Okay, we've divided. What's the next step? Distribute, so multiplying. So I'm going to distribute 7x times the entire dividend, including the 0 part. Don't forget my 0 part. Which means this is a triple distribution. Woo! 7x cubed, oh, let me write it, not there. 7x cubed plus still 0x plus 7x. Making sure, again, that your powers go in order, 3, 2, 1. That's what I write down underneath. 7x cubed plus 0x squared plus 7x. We have divided, we've multiplied. What's the next step? Subtract. But instead of subtracting, what do I do? Add. Change, 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 change. Yes, there's no such thing as -0. I get that. Just play along with me for a second. 7 plus -7 cancels out. 1x squared minus 0x squared is just 1x squared. 7x plus x plus -7x is -6x. Ooh. What's next? Bring down. Say again?
Is the x minus, is not x minus 7?
It is x minus 7, so it's 1x minus 7. 1 minus 7 is -6. So we bring that down, and we repeat. But look, we just brought down the last term, so we're on the last repeat. We're not going to have to do this another time, because we just brought down the last thing. Okay. We divide. This time we are dividing x squared by x squared. Well, don't those just cancel each other out? So this is going to be 1. We like when it's 1 because that makes the multiplying very easy. 1 times anything is that anything. So I can automatically know 1 times x squared is x squared, 1 times 0x is 0x, and 1 times 1 is 1. That's the distribution step. I'm doing it in my head. If you need to show it, show it. We subtract that. But nope, we don't subtract. What do? Change, 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 change so we can add. First part cancels. Has to cancel, should cancel. Then I have -6 plus -0. It's just -6x. Then I have 3 plus -1. That's 2. Is there anything else to bring down? Which means, what is all of this called? That whole thing is my remainder. Ew, what? It's a whole polynomial. That's okay. It doesn't just have to be a number necessarily. It can be a whole nother like plus minus situation happening. So if we wrote our absolute quotient here, including the remainder, it would be the stuff from the top and the remainder divided by the divisor. My remainder was 6x plus 2, and my divisor is x squared plus 0x plus 1, which we can just write as x squared plus 1. Oof. My goodness. You did it. You survived. Polynomial long division is not easy. It's not a joke. Okay. What I want to do for the rest of class, we've got like 30 minutes. I want you to work on your homework. You're going to be very happy with the fact of there are only 4 questions on your homework for this lesson. Okay. Now, this lesson does require you to show your work, which means either grab a separate piece of paper, grab a notebook piece of paper, flip your notes over to a blank side. I've got paper in the back of the room. If you want to do it on a whiteboard, that's fine too. But you have to be showing me work. That way you can ask me questions and point at parts and be like, what's happening here? And then I can help you. Okay, so everybody's logging into their homework. We're going to work on our homework for the next 30 minutes.